Hi, my name is Asad. Currently, I'm doing OSSD. This video is for my MCV assignment Unit 7 video presentation Vectors with Force. As I told you, what are vectors? Vectors are the quantities which have magnitude, which is called size, and direction both. In maths, the significance of vectors are that it is used for the quantity which are having magnitude and direction both. And the real life example can be that if you are given if there's a cup of coffee on a table like this and you are blindfolded and you are asked to and they turn you around so many times and you are asked to find the cup of coffee and people are saying that it is here, it is there, and you don't know. But if you know the magnitude and the direction where it was, so it will be easy for you to find. So like this we have a lot of examples, but let's stay on this example for this video. So now, as in last one I told you what is resultant force. In this one I will tell you what resultant force and equilibrium force. Resultant force, say that we have a resultant force like this 60 newtons, and if you this is a resultant force, if you can say that this one, and if you and let me tell you what is equilibrium force. In this force happens when nothing is moving. So if a force is going this side from an object, so it's moving right in this direction, and if you want to stop it you have to have an equal force this side of 60 newtons to stop this object. As I told you, equilibrium force happens when nothing is moving. So if this side the force 60 newtons and this side the force 60 newtons, so this object cannot move, it will stay on this position. We can call this E. So let me tell you, let us start with an example. If you have an object over here and the force are going in two different directions, as we can say this is 40, this is 30 newtons, and if you have we have a angle over here 60, but to get a resultant force you have to add this one, this side, which we can say that we're adding this like this. So we'll be having 40 here, 30 here, but there will be angle in between over here. And if we know the parallelogram theorem for the vectors, so we can find this angle like this. As we knew this was 60 and this is a straight line, so this is a straight line, so this full angle will be 180, which will be deducting 60 from 120, which will become 60 from 180, so it will become 120. So then this is the resultant force over here, and this angle is 120, and we have to find this R. So now, as this is not a right angle triangle, there is no right angle. So now we will be using the cos formula, which will be 40 square, one side square, then plus another side square, minus 2 one side, then another side, then the cos, as it's a cos formula, with 120, which we have the angle over here. You can use your calculators, but I know what the answer it is. It will get this one, after finishing all this, we'll get this. After squaring it both sides, we'll get 60.8 newtons. So this will be 60.8 newtons. So now let's find the angle over here relative to 40 newtons. So as you can see that we can use the sine formula over here. So let's use the sine formula. It will be sine 120 over 60. As in this formula we always take the opposite sides. So 120 is opposite side is this one, is equal to sine theta, and the opposite side for this one is 30, so opposite 30 newtons. So now it will look like this. Once you multiply this with this over this, and then as we want the theta, we will bring the sign here. Sine inverse is equal to this. So after using your calculator, you'll be getting the answer, which will be 25 degree for this one. So if we have this 25, so now we have to find for the 30 newtons. So we'll make this line over here 30 newtons relative to 30 newtons. As we had this line already, I am not making a new line, as we had this line already. Now we have to find relative to 30 newtons. So we knew that this full angle was 60, and we know this, if this is 25, so we will minus this from 60, we will get 35 degrees. So this will be 35, so it will be 35 degrees. And now let's go to the equilibrium. As we know that this is the resultant force is going this way to 60.8 newtons, so it's obvious that the equilibrium will go this side 60.8 newtons. So the magnitude for this one will be the same, 60.8 newtons. Now let's find the angle which is over here, which is this one, relative to 30 newtons. So as we know, there is always a straight line between resultant and equilibrium. So this is full 180, and we know that we have this angle 35, so this will be 180 minus 35, which will make it 145. This is the angle which we are getting relative to 30 newtons. Now we have to find relative to 40 newtons. So now we will take this for this angle. We will be doing the same thing. We know that this complete is 180, and we have this angle 25, so we will minus 25 from 180, we will get 155 degrees. So this will become 155 degree. So I forgot to tell you guys one thing. In this one, in vectors, we can use force, as force have both magnitude and direction, so we can use vector with force. I hope you got all the points which I have told in this video. Thank you so much.